everyone. Good morning. Wow. So I was not expecting this much audience for the session, but again, another time for another technical session. So let's just start. Okay. So what we are going to do, or what we are going to talk about, is the express storage architecture, which is a new concept in vSAN 8. And we'll talk about what is it, why VMware had a need to create it, and maybe more interesting things around it. So let's start. Okay. So before we jump into what is this architecture, let's first understand, how technology, how industry, and how the customer needs have changed over the course of time. So if we go to the next slide, please. Yeah. So in a decade ago, like, we used to have your on-prem data center, like a 3-tier architecture, right? We used to have your media type for any shared storage used to be your hard disk or your SATA drives. And SATA drives used to have the NAND protocols, right, which used to have very less capacity with very legacy bus protocols that will also maybe have some performance issues also, right? Even the networking that was used before was approximately 1 gigabyte or 10 gigabytes of Ethernet, right? And in this scenario, the VM workloads are restricted to on-premise data center, your just on-premise data center. If you look today's modern infrastructure, your NAND devices, NAND flash devices, are now drastically changed to your TLC or QLC flash devices, right? They also uses NVMe performance, high performance protocols. They have, even for the networking, they have like we use 25 gigs or 40 gigs or even 100 Gbps of Ethernet, right? And the workloads here, they contain high intensive applications, which has high intensive resource intensive VMs, and then you have resource intensive containers as well. Also, these workloads are not limited to just your on-prem or on-premise environment. They extend up to your public cloud providers and VMware cloud providers, right? So this whole evolution has changed the equation of our customers and VMware as well, both. And VMware observed and VMware understood that there is a need to incorporate a new architecture, maybe use the same software, but have some different architecture on the same baseline that we all been using from such a long time, right? So they have identified few opportunities, and the few observations were made based on customer requirements. A simpler solution was created based on what were the requirements and what were the observations that were there in the market. That brings us to what is vSAN 8 ESA. So it's actually an optional alternative architecture. When I say optional and alternative, it means that it is not replacing your original storage architecture. It is just that it's a new architecture in the same software that you know, just that it's the architecture here is changed. I'll go into deep dive in each of these components one by one, but wanted to give you an idea that it's the same architecture. You don't have to replace it. vSAN 8 is not replacing any previous architecture. Even you can use both the architectures in the same environment and work together and they can coexist together in the same environment. Right. So before we understand what is vSAN ESA, let's understand what was earlier and what it is now. So earlier we used to have vSAN original storage architecture, which was nothing but a two-tier architecture where you used to have like dedicated cache, dedicated capacity disks, right? And used to combine them together in a disk groups, and then maybe have a required outcome, or maybe define the FTT and RAID group levels. Here, they also accommodate all kinds of storage devices, the older storage devices in this architecture. When I compare it with ESA, which is the express storage architecture, it is nothing but there is no concept of disk groups here. So you have a concept of single pool where your disk groups, where you don't have a capacity or cache disk. It's just your storage devices all combined together in one storage pool. The only difference here is that when you say it's devices, the devices are all high performance NVMe disks, and they are NVMe flash devices. You just connect them and you create a storage pool. That's it. So no disk groups, it's a flexible architecture, and that's when it's a single tier architecture. Now let's understand what is this solution. This is just an overview. What exactly is this solution from a technical point of view? Okay, right. So what you see on screen is in vSAN 8, there were two major elements that were introduced. The first one was a new log structured file system. We call it as LFS, vSAN LFS, which is introduced in the upper stack of the vSAN layers. And there is another, which is improved IO engine. So we used to have object manager, if you are aware about vSAN. We used to have object manager that was now in improved IO engine and data structure, optimized data structure, which helps in storing the data in a much faster way. So we'll look into both of them in a more detailed way in next slides. Yeah, the first one is the new log structure file system. I'll need some time to maybe explain this. So what exactly it does is, from as soon as the data is ingested, it helps you to ingest small IOs one by one, and then it combines them and then write a larger block. As soon as it writes a larger block, it saves that block to the durable log. Now, durable log, when you see in here, is a part of a performance leg. So here, when I said that, right, that you don't have a cache disk or you don't have a capacity disk, but you do have some performance leg and a capacity leg inside a storage pool, so that you can segregate what is required for performance and what is required for capacity. So in here, when you write that larger block to the durable log, what it helps is, it helps in the faster write acknowledgement, because the data is not going to the end. It's coming directly from the durable log. And as soon as the new log entries that comes to durable log, the older entries are then pushed to the capacity leg, which is at the end, right? And it is when it is pushed to the capacity leg, the metadata log, and there is something called as B-tree protocol. It's a bus protocol through which it writes the data to the capacity leg. So this is the main or primary reason why vSAN 8 is able to provide RAID 1 mirror performance with RAID 5 and 6 levels. So earlier we used to struggle with RAID 6 performance because we all know that RAID 1 performance is the best, right? But here with this solution, you can have RAID 6 as well to have a maximum space efficiency plus the performance of RAID 1, both in the same solution. The second element that I mentioned was the IO engine. So IO engine was before also, it's just that it is now more improved solution where it can accommodate more modern storage devices. So as the technology increased, right, the NVMe flash drives, and even that will come along, or maybe that cater the containers, and that can cater the modern applications. You need a modern IO engine that helps you store the data in a very, very efficient way. So what it does is it is nothing but a high performance block storage, block engine. So it helps in storing the data and its metadata to the capacity leg in a much faster way, because the data, when it's written in a full stripe mode. So I'll speak on this on full stripe mode how, but this is how this engine is working. You can see what are the benefits, but this is how it is working at the back end. Right. So now data is distributed, since there is no concept of disk groups here. So the data is distributed here in a very different way. For example, here in the same object, you have a capacity leg, you have a performance leg, right? Exactly like your cache disk and your capacity disks that we used to have. And then we used to combine them into a disk group and then create FTT and RAID levels. In here, you have a single storage pool where you have capacity and performance leg. And then this particular object combines or maybe interacts with your log structured file system, the new file system that was there. And then the FTT and RAID levels are defined. So these are some of the examples how the FTT and RAID levels are there in RAID 5, RAID 6, or even RAID 1 kind of levels. But just to make sure that the performance leg always prefer a RAID 1 mirroring, and the capacity leg is preferred to have a RAID 5 and RAID 6. When it's combined, the FTT solution, or sorry, the FTT domains that is defined, it's perfect. So this is for vSAN 8. Again, vSAN before versions are really good. They are working as before, but this is something which is new with ESA. Right? Let's have a quick look on the benefits that are going in vSAN 8. So this is how a normal data services that works, right? You have compression, encryption, and checksum at each layer of storage device, right? When the data is ingested. But with vSAN ESA, what it does it at the time of ingestion only, the checksum, encryption, and compression, all three are done at the time of ingestion only. So it reduces your compute and network resources. It reduces the overall overhead, and it reduces the time taken for any data to come to the or maybe to write to the object. So this is one thing. And second thing is, when the data is written on RAID 6, it is written in full stripe mode. So it is when it's written, it's more efficient, it's more faster, and it actually eliminates read, modify, and write activities. Moving on. So yeah, this is again, it's the same thing that I've been explaining. It's because of the performance and the capacity leg. Simpler administration was also important. It also plays a very important role here. So here, administrators can now easily go to RAID 5 or RAID 6 levels with the same RAID 1 performance. And yeah, it's because of they have an equal level of resilience between the legs. So that's the same thing. I'll just move on. Right. So as I mentioned that, yes, you can definitely go with RAID 6 levels, but for RAID 5, you have actually two schemas which you can use. So first schema is 4+1 scheme. 4+1 scheme is nothing but your data placement spreads the data with parity across 5 hosts. And you would require at least 6 or more hosts to have this kind of schema. And then there is another schema, which scheme for RAID 5 is 2+1, which is nothing but your data placement spreads the data across, spreads the data with parity across 3 hosts, and you would require at least 3 to 5 hosts to have this scheme. Now, for example, in 4+1 scheme, you have 6 hosts, which is minimum required host, and one of the host or 2 of the hosts goes down. Now, what happens is you have a fault domain at that point. But in here, in this vSAN 8, there's this new concept where it automatically adjusts the policy to another scheme with checking out the number of hosts in a cluster. So without compromising on the performance, without compromising on any RAID 5 benefits, it would just change the scheme based on the number of hosts which are available in a cluster. And it would help, and for you, for an administrator or for a user, it will be the same kind of experience. You don't have to see or change anything. It's definitely automated. It's a dynamically adjusted policy. So this scheme is a very, very cool concept in vSAN 8. It's a very new concept. So if you actually remove one more host from here, it will automatically check which scheme is required. And based on the number of hosts in a cluster, it would just change the scheme. And if your host comes back online, it will again change back to 4+1 scheme, which originally was configured. Yeah, exactly like this. Right. So yeah, moving on. Right. So right. So I just mentioned that you have a dynamic storage policy. We have which is determined by cluster size. We don't have a concept of disk groups for any storage. Since we don't have a concept of this disk groups, then all the devices which are added directly becomes a storage pool. So removing of any storage devices becomes much, much easier and simpler than your disk groups, because you used to manage a dedicated cache, a dedicated disk for your disk groups. And it was a headache for administrators. But now you just have to add the storage devices and it becomes a storage pool. That's it. So it gives you much simpler operations, much simpler administration all across your vSAN architecture. Yeah. One more thing that it does is that it has an intelligent IO management. So as you can see in here, what it does is that in the times of network contention, your VM IO and resync IO try to manage the balance between each other, right? So when there is a bottleneck, between both the IOs, it automatically checks and see if, or maybe prioritize VM IO traffic above your resync IO traffic. So resync IO and VM IO goes on continuously. This is a very normal process that goes on at the behind of vSAN. But this is a new thing that has come up, that when at the time of network contention, it would automatically check that VMIO needs more resources, network resources, and it would automatically prioritize network IO traffic more than resync IO. And it helps you maintaining an optimal balance between both the IOs. So, and it ensures more predictable VM performance when it comes to network contention. Yeah, this is one of the really cool features. So in vSAN 8, you can take as many as snapshots of a VM as possible. There is no limitation to the number of snapshots of a VM that you can take without to worry about any degradation on a VM. For example, we used to have, I believe many of you have encountered an issue with snapshots, right? So your stun time, if you have a higher snapshots for a single VM, and if you try to consolidate them, you will have some issues with the performance or something on the stun time, right? In here, because of this new architecture, you can, first of all, you can have as many snapshots as you want. Second, there will be no performance degradation of VM. There will be less stun times in here, and there will be a consistent way of working when you have a snapshot. So this is one of the things. Secondly, all these snapshots, or it's the same it's the same third-party backup providers that we support. So in vSAN 8 also, it is the same vSAN third-party backup providers that we have, and it is supported within VMware. This particular feature is integrated with vSphere directly, and then all the third-party backup solutions are supported in this. So with vSAN 8, it's only available with vSAN 8 that you can have as many as snapshots that you want. Also, one more thing, that now you can directly see in the vCenter how much snapshot usage that you have. So earlier we used to have VMDK, snapshot VMDK used to calculate how much snapshot is taking the space at this backend. Now you have an option to actually see the snapshot usage on the vCenter console itself, on your web client, as in, right? So this is a very nice feature. Yeah, so it was a small session, I feel. Okay, so the quick takeaways is that vSAN 8 gives performance without trade-off on efficiency. It gives you a supreme level of space efficiency with very adaptive range on RAID levels, RAID 5 and RAID 6, right? It gives you much simpler operations, deployment, and overall a simpler architecture. Again, I'm repeating, vSAN ESA is not replacement of the original architecture. You can still use both the architectures in the same environment, and they can easily coexist in the same environment and work together. It's just that this new architecture was built on the same software, and it may be the future, but both the architectures are supported by VMware and will be supported for many years to come. So yeah, that's all I have to cover. Any questions?
Thank you, Arpita.
Thank you.
For question and answer session.